right, I think that's going to do it for the first model. If you enjoyed this first model, be sure to hit the like button. Let's move on to another example of real-world parts designed using Onshape sheet metal lofted bends, and that's going to be this one here, the air duct adapter. So for the air duct adapter here, we're going to go to our we're going to create I'm creating a new part studio here. So again, just so you can see this, I'm going to go in here, I'm going to create a new part studio. I'll call this one air duct adapter. And for this one, we're going to be going from a 4-inch diameter vent up to an 8-inch diameter vent, and the transition is taking place along kind of a lower edge here. Now, I really wanted to show you this one because I think it's pretty cool how you can use Onshape in combination with the sheet metal model. So what we saw a moment ago is that if we do have a sketch which is open, we can just take that open sketch and we can use that open sketch to create, in this case, to create our sheet metal model. So I'm going to create this one directly above the origin, and I'm just going to make it tangent to the origin. This just makes it a little bit easier. So I make a 4-inch diameter circle, and I create it in a way that's vertical to the origin, and this point down here is directly on the origin. And then what I'm going to do is I'm just going to make 2 lines, a line that comes up here from that lower point, and then a line that comes out this way. And then I'm going to use those 2 lines to perform a trim command. So trim, and I'm just going to kind of trim off this little kind of extra section here of that wedge. And then what I'm going to do is I'm going to take those lines and make them construction. So Q, and then I'm going to take a dimension here, and I'm going to create a dimension here that goes from this point to this point. And that dimension is going to be 0.060, 60 thou. So now I've got the perfect geometry to turn into a sheet metal extrude. So I can exit that sketch, I can click on that sketch, and then I can choose sheet metal model. If you click on the sketch first before you jump into sheet metal model, then what will happen here is that you'll end up with the extrude pre-selected and your sketch pre-selected. It's kind of nice. So you just pre-select it there, and then for our thickness here, we'll go back to 60 thou, and then for our bend radius, we'll go back to 90 thou for our bend radius. Here you see we can flip the direction. Let's put that material to the inside, and then for the depth of this, it really doesn't matter. I'll make it 3 inches for the depth. Just some arbitrary value there. Now what I'm going to do is I'm going to create an offset plane here from the right plane. So if you take the right plane and do an offset, so right click offset plane, and let's reverse the direction of that offset, and then let's offset that to 6 inches. Okay, so offset that plane over there to 6 inches. And then what we could do is we could reuse the work that we put in on sketch 1. We could take sketch 1 here, right click, copy sketch. Then we can go down here to plane 1, right click, paste sketch, and now we can double click on that new sketch and we can kind of reuse some of that geometry. So N, get ourselves normal 2 here, and we can say that we want this diameter to be 8, and we can say we want this point on our new sketch to be coincident to the origin here. So coincident to the origin, maybe you have to zoom in a little bit there. And then I use I is the shortcut for coincident. And then I think if we just make this line vertical, that should take care of it. So this line here, V, and there we go. Nice, fully defined sketch. So a lot of times it's good to be able to copy and paste a sketch like that. So now that we've got that nice, fully defined sketch, what we can do is we can once again exit the sketch. So hit the green check mark here, exit the sketch, click on the sketch. And then when we click on the sketch, we can go in here to sheet metal model. And then right away, that puts us into our sheet metal model. So depth is going to be 3. We're going to reverse the direction on that. And then what we're going to do is we're going to go here to our thickness and make sure our thickness is going to the inside, just like the other one, thickness going to the inside there. And there we go. And now what we're able to do is we're able to loft using those 2 edges. So over here in our sheet metal tools, we can go to sheet metal loft. Now, I have noticed with this command, it seems like, at least with this example, it tends to work a little better if you pick the outer edge. I'm not exactly sure why. It's just a little pro tip that I've noticed. Sometimes if I pick the inner edge, it doesn't work, but if I pick the outer edge, it does. So for profile 1, I'll pick this edge here on the outside, and then for profile 2, I'll come over here and I'll pick this edge here on the outside, and There we go. There is our preview of that sheet metal lofted bend. Now, you'll notice here that we've got this chordal tolerance 0.05. If we make it 0.01, Onshape will probably chug for a second there, and then it'll update that. If we make it 0.1, then we end up with this kind of more fragmented, more tessellated shape here as we're going around. So just like in the earlier example, we're going from one planar face to another planar face to another planar face, and at the intersection of each of those faces, we're working with a bend radius, in this case 0.125 as the bend radius. Now, if you are working with a customer and you're showing them these parts, one thing that you can do is you can go into the view flyout menu here, the camera flyout over on the right here, and from that camera flyout over on the right, you can turn off your tangent edges. So when you're working with sheet metal like this and you're doing a lofted bend, you can turn off your tangent edges, and then it tends to be a little bit less obvious. So you go tangent edges removed, and it tends to be a little bit less obvious, especially when you get a tighter chordal tolerance in there. So if I go back here to my sheet metal loft and edit that feature, and then let's say we make that chordal tolerance 0.05, and then we hit the check mark. See, it doesn't really jump out as much when you can't see those hard edges on that tangent connection there between those different faces. Now, another thing you'll notice here is that I didn't really take care with regards to the direction of that lofted geometry. So let's go back to that sheet metal loft, and then let's take a look here. Here's our wall thickness for that sheet metal loft, and then here's our bend radius. So we're going to flip that in the other direction, and there we go. And so now that we've created that shape, we can hit the green check mark, and we can always come over here to our sheet metal flat pattern view, and then we can choose that item. So you've got your sheet metal model 1, that's this sleeve here. You've got your sheet metal model 2, that's your gray sleeve up here, so you can get the flat pattern for those. And you've got your lofted sheet metal, and there you go. There is that flat pattern. And a lot of times that's what the team out on the shop floor needs. They need that flat pattern so they can bend this thing up. So you would just right mouse button here, export to DXF DWG, and then bring it into your other program to get it out to the CNC. So that is the lofted sheet metal bend going from one profile to another. Now, what you're going to end up with here is you're going to end up with a situation where the seam is running right up through the middle here, and that may or may not be what you want. So there is another option here. Let me get rid of that sheet metal loft. The other option would be to recreate the circles here on these faces. So I could go to this face here. I could begin a new sketch. So this face here, begin a new sketch. And then what we could do is we could create an 8-inch circle here. So we could go to the center of this existing circle, and then we could maybe come out to this point or this point here. Nice fully defined sketch there. And we'll close that sketch. And then what we can do is we can go to this one down here, and we can do the same thing, but we're going to add one extra feature to this sketch. So we'll begin a new sketch here, and we're going to create a circle. So S key circle here, and we're going to create a circle here right at the center, and we'll come down to this point. And now for this one, what we're going to do is we're going to create a point where we want this thing to have a rip, so a connection point basically. So we'll just create a sketch point here, and we'll create this sketch point directly above the center point of the circle. So exactly vertical here to the center point of the circle. There we go. Okay, so we create that point there. There you can see what that point looks like. And now we're going to exit that sketch, and now we're going to do the sheet metal lofted bend function. So sheet metal loft. And for our first profile, we can choose here sketch 3. Can just pick it right from the tree. For our second profile, so click in this box. For our second profile, we'll click here in the tree, sketch 4, and then what we can see is what that lofted bend ends up looking like. But now what we can do is we can choose connections, and we can choose this point here from our sketch. So you can choose this point here to define the connection, but that's not really what I wanted from this thing. I really wanted to go from this point, which is vertical, up to this point here, which is vertical. So what can I do? Well, I can edit that other sketch. I can go back to sketch 3 here. So I canceled out of the lofted bend. I can go back to sketch 3 here, and then in sketch 3, what I can do is I can just edit that sketch and add a point to this sketch as well. So we'll kind of wake up that center point and create this point here directly above that point. Connected. All right. And so now we're going to hit the green check mark. And now let's create that lofted sheet metal again. And we can sheet metal loft here from sketch 3. and then down to sketch 4. And now for this one, we can say we want to use the connections, and we want the connections to be this point, and we want the connection to be this point down here. Okay, so it's already kind of got that other point there, but let's just click on it there, make sure it gets it. There we go, to that point there. And then we can say that we want that to be the location of our rip as well. So we click here for rip, and see Onshape automatically move the rip over to where those connections are. And remember, when you're trying to control what the opening of that rip is, you go in here to the option for relief, and then you can adjust this minimum gap here. So 0.010, make that gap just a little bit tighter there. So that is how you can use sketch points in your sketches to define how that connection is taking place. Maybe there's a situation where you want it to kind of go off at a weird angle. Well, you can do that as well by putting in different points in your different sketch profiles. And that is the takeaway from that section of the lesson. And just because this is going to bother me if I don't fix it, I am going to edit that loft and just change the direction of my sheet metal thickness, get that to be going down into the inside. All right, well, I think that's going to do it for that example, the air duct example. Let's move on here. We got a couple of final examples here. We've got the round to rectangle adapter. This one, I think, like I said, is probably the most cliche example in the world of lofted sheet metal bends, going from a circle to a rectangle. Very commonly demonstrated. So let's give it a try and let's see if we can control where that rip is going to take place. So once again, I'm going to create a new part studio here. And once again, I'm going to rename that part studio. And I'm going to call this round to rectangle. And don't forget, if you're liking this video, be sure to hit the like button on this video. Be sure to leave us some comments down below. Let us know if the video is too long, too short, if we're going into enough detail for you, if we're not going into enough detail for you. All right, and we're going to go here to the top plane. We're going to right click and begin a new sketch. We're going to get normal 2 here, and we're going to create a rectangle on the top plane. Let's create this rectangle with the dimensions of, this looks like it's probably about 12 by, I don't know, 12 by 8 inches. That looks like about that. And then we'll exit that sketch, and now we're going to go to the top plane. We're going to right click on the top plane, and we're going to choose offset plane. And we're going to offset this plane up here. Let's offset this up by about 8 inches for that transition area. And then here on this top plane, on this new plane that we just created, we're going to begin a new sketch. So begin a new sketch here, and we're going to sketch a circle. So we'll drop in a circle here directly on the origin, right in line with that rectangle, and we'll give that circle a diameter of 6 inches. So we'll hit the green check mark, and there we go. And that's it. That's all we have to do for our setup. Now we can choose to create our lofted sheet metal, and we can say that we want to go from this profile down here. I'm just going to kind of click inside the rectangle up to this profile here, like so. We see we get the preview. Now, once we've got the preview up there, we can flip the direction of our sheet metal, have the sheet metal go to the inside, have the sheet metal go to the outside. We can increase or decrease the number of bends in each corner. So we can adjust our quartile tolerance here, let's put it at 0.02, and see what that ends up doing in our corners, make our corners a little smoother there. And then what we can also do here is we can create some connections. So if we want this thing to rip at a very specific location, we can choose connections here. And now instead of needing to sketch a point, we can just kind of come down here and infer the midpoint of the rectangle. And that will give us a nice connection going right from the midpoint of the rectangle right up to that circle. Let's choose to include a rip there as well, so that we can define this thing as ripping right up along that location. And then let's just go into our relief down here, and in our relief, let's make sure that we've got our gap set. Let's put that back to 60 thou, 0.060. And once we've got that geometry, we can hit the green check mark, and boom, there is our sheet metal lofted bend going from a circle to a rectangle. Very common shape that we see here in HVAC. Usually there's some flanges sticking off the bottom here, so let's create those as well. And to do this, we're going to once again use our little trick, begin a new sketch here on the front plane, sketch a line here that comes down like so, hit escape, hit the green check mark, and now we go into sheet metal flange. And for the sheet metal flange, what we're going to do is we're going to pick this edge here, right near our rip, and then we're going to say we want that to be 2 inches. We'll make this one 2 inches this time. And we're going to say that we want the angle. We don't want the angle to be 90 at a bend. We want it to be aligned to geometry. And we want this to be parallel to, and then we'll click this line here. And once we do that, we see Onshape attempting to update. Sometimes you have to click here opposite side to get this to update because we want it to be sticking down, not up into the material. Normally what I would do is I would pick this edge and this edge, get those two to kind of finish rebuilding, and then I would pick this edge here and this edge over here, kind of get those two to rebuild, and then I would finish off by picking the one on the back, kind of like work my way around symmetrically. There you go. Hit the green check mark, and there you've got your transition. We already know how to create the extra sheet metal shape up top, so we won't go over that again, but here we can take a look at the flat pattern and see what this looks like, and then as always, we can right click and we can choose export to DXF DWG. All right, I hope you guys like that one as well. And we've got one final example to show you here, and that is the more exotic range hood here. So we really saved the best for last. If you're enjoying this tutorial, be sure to hit the like button. Be sure to let us know if you have any questions down below in the comments as well. But let's get into this last one. One more part studio here. I'm going to choose to create a new part studio. And after creating this new part studio, I'm going to rename it. Because this document is in the public space if you want to take a look at it. I'll call this one Range Hood 2. And for this one, we're going to start out a little bit different than we did last time. Actually, a little bit the same as how we did back here on Range Hood 1. So Range Hood 1, what do we have? We had a 20 by 30, and then we blended it into a 12 by 12 with a 1 foot gap going up. So let's do the same thing here to get started. We'll go top plane, begin a sketch, S key, rectangle, and we'll create a rectangle here. We'll make this rectangle 30, enter, 20, enter. Okay, looking pretty good here. And then we'll hit the green check mark. And then what we'll do is we'll go to the top plane. We'll right click and say create a new offset plane, and we'll offset this to 12 inches. All right. And now on that new plane, let's begin a new sketch, and we'll create a new sketch here, S key, rectangle, and we'll make this one 12 by 12. 12 by 12. Now, this is where things are going to start to get a little bit different, because now instead of jumping right into lofted sheet metal bend, we're going to do this as a regular loft. Now, the reason we're doing this as a regular loft is because the customer wants this to transition out here, wants to have this kind of exotic bend here, and they want this to be at a very specific method. So maybe what we would do when we create a standard loft is we would get in here and we would create a guide curve. I'm going to use a different technique today just to save some time, but that might be something you would do. You might get in there and create a guide curve to match the customer's design. But in this case, what I'm going to do is I'm going to choose to create a regular loft, and I'm going to loft from this profile, from the upper rectangle down to this profile to the lower rectangle. And then in the loft command, you've got this option here, start profile condition. And what you can do here with the start profile condition is you can say, I want the loft to start off perpendicular to the sketch plane. So here's the sketch plane here, and I want the loft to start off perpendicular, and then I want it to kind of blend out. And that way we'll get, a similar scenario to what the customer has asked for. So here's start profile condition. I'm going to fly out this menu here, and I'm going to say normal to profile. Now remember, I picked this one first, so that is my start profile. If you pick this one second, then that would be your end profile condition. But here you see I picked the start profile condition, normal to profile, and then you've got this start magnitude. So how heavily is that normal to condition maintained before it starts to transition over here to the other loft profile? So for example, if I make that 1.5, it kind of remains straight for longer. I think that looks pretty good like that. If I made it 0.5, then it almost immediately makes that transition. I don't like that at all. So I'm going to make this one 1.5. If you're following along with, you can make yours 1.5 as well. So now I'm going to hit the green check mark, and now what have I created here? I've created a loft. Now, I'm not sure why that loft is hollow. Hold on, was I on thin feature? Oh, I was on surface. Oh, I clicked into surface by accident. Okay, remember everything I just said. Just do it as a solid. So we'll do it as a solid here from this rectangle to this rectangle, and we're going to do it with the normal 2 profile and the start magnitude of 1.5. It really doesn't matter. I could have done it as a surface or a solid, because when we're done here, we're going to ignore all this geometry anyway. So now, what are we going to do with this geometry? Why did we make it as a solid loft? Why didn't we make it? I thought we were going to use the sheet metal loft here. Well, now what we can do is we can use the sheet metal loft to go from this edge to this edge. So we can use the sheet metal loft here, sheet metal loft. So here's sheet metal loft to go from this edge to, that's profile 1. Now click in this box here, to this edge over here, and we can actually create a sheet metal lofted bend to connect those 2 together. And so now at this point, you're going to decide if you want the material to be to the inside or to the outside. You can decide how much material you want on there, and you can decide how many segments you want there to be. If I make this 0.01, then there's going to be quite a few more segments on that thing. If you think 0.05 is enough, then you can just leave it at that. And of course, you could always look at it in the flat pattern to see what this ends up looking like. So I'm going to make that 0.05. I'm going to hit the green check mark. Let's say that maybe the back side of this thing is different from the front side. I know that they are identical, but let's say they were different. Again, lofted sheet metal bend, this edge here. Go to my second profile, this edge over here, input the chordal tolerance, hit the green check mark. Now I can come down here into my bodies or into my parts, and I can hide these 2 parts here. So we're going to hide this first part, hide the second part. Now we can do the same thing on the sides of this thing. So we can go here to lofted sheet metal. We can go from this, click up here in this box. Remember to click up here in this box to this. Okay, and hit the green check mark, and then we can do it one more time on the other side, lofted sheet metal, and we're going to go from this, click up here in this box, over to this. And now we hit the green check mark, and now we can show those original bodies. So each one of these is its own sheet metal body. Each one of these can generate a flat pattern, and that can be exported to DXF. So you can see here, we can go through, can look at the 2 that are the same. We can look at the other 2 that are the same. Okay, and now what we can do is we can click on that first original body, and then what you do is on your keyboard, you press the delete key. And what this does is it deletes that part. So you see here, we've got the delete composite parts, and it says parts to delete, and then we hit the check mark. And now what happened is that part has been deleted. It's a new feature in the tree. So if you roll this bar back, you can see here that that part was there. That part was used to create these lofted sheet metal parts, and then that part was deleted. So it's a new feature in the tree, so you don't lose the integrity of the tree by adding that feature. You click on the body down here, and then you press delete on your keyboard, and that adds a new feature to the tree to delete that part. Pretty cool, right? So now, I know this is a little bit of rinse and repeat, but I just think it's worth showing. And we're always trying to sprinkle in some new functionality. Now we can use the same trick we've been using. Front plane, begin a new sketch, sketch a line, bring that line straight down like so, exit that sketch, sheet metal, flange. The flange is going to be applied on this edge here. The flange is going to have a length of 3 inches. And that flange is going to be aligned to geometry, and it's going to be parallel to this new line that we just created here. So now we've got that flange there, and now what's so cool is that in Onshape, you can apply edge flanges to multiple parts, to multiple bodies in one single command. So I can go around here and actually get all 4 of these in this one single command. And there we go. So now, as kind of a final little cool tip trick type of thing you can do here, you know, we've mentioned already that what we could then do is we could create a new sketch up here. Let's say we wanted to make a sketch for sheet metal, and we wanted the rip to be right there. So what we could do here is we could create a sketch like this, and then we could do the sheet metal command for sheet metal model, and it would extrude it, right? We're very familiar with that. We've done that many times. But check this out. Another way that we could accomplish this is whatever we want the length of this upper section of the hood to be, what we could do is we could create a new plane offset from this upper plane that we created here. So we've got plane 1 in the tree. We can right click on that, and we can choose offset plane, and then we can choose to offset that. Let's say we're going to offset that up 18 inches. and we'll hit the check mark. And then let's go to that plane and let's take this sketch here, sketch 2. So let's go to that new plane. Let's begin a new sketch on that new plane. And then let's go to this sketch 2 here, which was the sketch for our upper rectangle. And let's choose this button in Onshape sketch mode, use project convert. So we take that rectangle, we just use project convert it, we bring it up there to that upper area. Okay, so now we're going to exit that sketch, and now we're going to show sketch 2 again. So here we see we've got sketch 2 that we had used a little bit earlier in the process. We used that to create our original loft. Well, now we can go back to sheet metal and we can say we want to create a lofted sheet metal. So sheet metal loft here, and we want this sheet metal loft to be between our brand new sketch that we just created, sketch 4 up here in space, and for profile 2, we'll go back to that original rectangular sketch, sketch 2. And check this out. Now, Onshape is creating that lofted sheet metal shape for us, that rectangular shape for us. And what I really love about this command is I can then go to connections, and I can choose from the connections the inferred midpoint here on the back side of this thing. And then I can choose to rip that sheet metal part there so nobody will see that rip. And we hit the green check mark and boom. And that just to me feels so much faster, so much easier than creating a new rectangular sketch and then going in and putting in the gap manually and then extruding it. Instead, we could just use that sweet sheet metal lofted bend tool. So that's going to do it for today's tutorial. We went almost exactly 1 hour long. I hope that you enjoyed this tutorial. Let me know down in the comments what your favorite tip or trick was that you learned from this tutorial. We really covered a lot of material, but I think the best way to learn more about Onshape is just to go through and model up some real world parts. So I was really excited to share these examples with you. And if you enjoyed this tutorial, be sure to hit the like button. Be sure to leave us some comments down below. And I will look forward to seeing all of you in the next Onshape step-by-step tutorial.